Matteo. Hey, Brian.
Hey, Luca. Hi,
Hello.
Brian.
How are you guys doing?
Whoa!
I'm good. A little tired, but I'm good.
Great. And I see that you carry a nice t-shirt. So today is a strange chat because we have Italy, Canada, and both. So that's kind of like the mix and match of our chat. But Brian, as you know, Matteo and I every week find the time to kind of banter on something. And we were just like, Matteo had this idea of talking about this very nerdy. This is the second nerdy episode in a row. And the third one, I think, is going to be something a little bit more relaxing, hopefully. But today I feel that I will not be on stage for Matteo's interrogation. So that actually makes me feel better. But,
interrogation. Wow.
Oh yeah.
Interrogation,
They're
yeah,
not. They're actually not really questions. They're pure interrogation. Like he puts the lights on me. Like last time that he was asking about the set immediate, completely out of the blue, right? Even catching somebody out of any sort of guilt. He said, "And you know what it is, right?" And I said, "Yeah, just give me a second to breathe with my brain." But yeah, and luckily, my answer was correct. I felt pretty, proud of myself. But today we are going to talk about something pretty interesting, especially when Matteo and I have been chatting about multi-threading, asynchronous, and so on for quite a while. Sometimes also self-promoting what we did, very honestly. But today we talk about async context, which is kind of like a topic that I think touches you both. But Brian, before we dig...
It touches us all in one way or another.
Also me.
I mean,
you are in the middle of it. You are in the middle of it, Luca. You are in the middle of it.
Async context touches everyone. That's it. As long as somebody is deploying Node somewhere, we have to deal with async context somewhere along the line.
So maybe before starting to tell why, Brian, do you want to introduce yourself? The 2 or 3 people that don't know about you in this world, tell them who you are.
Sure, I'm sure there's more than 2 or 3. So yeah, I'm Bryan English. I work at Datadog. I'm a staff engineer at Datadog. I work on our APM product, in particular the Node.js tracing code. So if you do npm install dd trace, a lot of my code is in there. So naturally, that lends itself to the topic of the day, async context. But yeah, I've been working in APM at Datadog since late 2019. I've been working with Node since roughly its inception, however many years ago that was. It feels like forever ago. Yeah, that's pretty much me.
Super. Then let's jump into this async context, because now I'm curious, how is it touching us one way or another? It probably touches both our hearts and our wallets. So we're going to explore both. But I don't know who wants to start. Theo, do you want to start and then you bounce the ball to Brian? You guys play ping pong.
Absolutely. Let's bump it around. So what is async context? Okay. You probably use it, everybody that you're watching anyway, you're using it in 2 possible ways today. Okay. The first one is the technology that allows React server components to exist. You might care, not care, we have that responsibility on our shoulder. We'll talk about that, why we have it. But anyway, we have that responsibility on our shoulders. Okay. The other one is by providing tracing. What is tracing? It's distributed tracing, okay? Which means that allows you to, see the flow of data and the number of asynchronous calls and so on and so forth that are being done in the flow of a request. Now, why is that important? Specifically in a project like Node.js, because in Node, you are receiving your request with one thread, managing the request with one thread. And so there are multiple requests that are being executed that are alive at the same time in the same thread. So you cannot use the context of thread local. In Java, old school, you will start a thread local. So you have one thread per request, fine, and you have a thread local for it. Threads are too expensive to have one for each request. So event loops are born. With event loops that are born, you need something else to store that same information that you will put in the thread local, and now you need to put somewhere else. Where it is, let's go to that in a second. The other thing that you need it for, okay, you have this information about the request and all this metadata about the request. Now, the other problem is what happens when you are in a microservice system or a multi-service system. You need to pass that data around so that you know that service A is calling service B that is calling service C. And if service C has an error down here, if the fault is actually service A that sent bad input. So, and you want to know that, okay? And I have a very fun story about this to tell later. So, Luca, we can talk about distributed tracing. And I have this very fun story, and it's amazing. I recently fixed this fantastic bug using this distributed tracing that was insane. Okay, so that was fun. But what is this thing, this async context thing where we store this metadata, in this word, Brian?
I mean, there's a couple of different ways to think about this, right? So the easiest way I find to think about it is to think about callbacks, to think about writing code like we did in Node in, let's say, 2013-ish, before we had promises everywhere, right? Everything's a callback. And so when you're dealing with asynchronous code, the way your execution flows is very different from the way your procedural version of your function would actually operate, right? So yeah, sure, your function exits, but your control flow still continues because now you're inside a callback, and then you end up with perhaps one of these callback else situations. But that is where your execution context is flowing, right? So when we say async context, we're talking about data that is preserved along that continuation, along that flow, right? This is something that we can do manually, right? We can do it manually just by having a variable and passing it through or keeping it in scope, right? We do this all the time with web frameworks. We do this with the request and response objects in Express, for example. I'd talk about Fastify, but I'm more familiar with Express. Sorry.
Shame on you.
I know. I'm sure Fastify does something similar, right? You have access to the request and response objects or a context object or something like that all the way through. And so that's an example of manually passing asynchronous context around. Manually is great because it means something is very explicit. It's in front of you. It's not magic. The difficulty becomes the difficulty is apparent when we're dealing with something that is intended to be magical, or in some other ways behind the scenes, or just not visible to the usual code flow, right? So APM tools obviously are in that space, right? Because the objective of an APM tool is you just install it, maybe require import it at the top of your file, and then bam, your app is instrumented. Everything is great, right? That's kind of magic, but we need a way of doing that, right? Even if you're not trying to do something kind of magical like that, or in some way misdirected or whatever, you still might want to use something other than regular variables or something like that, because you may not have reasonable access to them. And so this is where we get something like AsyncLocalStorage as a useful tool. So AsyncLocalStorage is basically Node's abstraction over the concept of async context, just to give a place to store things throughout the continuation that is the async context. Yeah, if I remember correctly, there's a lot of history to this. We can go back to continuation local storage, which was invented at an APM vendor, of course, because APM vendors end up being the folks who use this kind of stuff quite a bit. And then, so continuation local storage did a pretty, these days it seems like a fairly simple thing. It just wrapped every callback so that it could store and then restore the context before and after the callback. Pretty simple, right? Then promises came along, And promises are interesting because as they exist natively, we can't patch them the same way we could patch every other function there is in the system. So we needed something a little bit lower level. And this is where async hooks comes in. And we could, that's potentially a fun tangent of conversation we can get into. But that leads into some performance things that we'll probably talk about later. Anyway, async local storage is this funny abstraction we have on top of all of this. Every APM vendor uses this directly or indirectly to store context, typically about the spans in your distributed tracing, so that it's not necessarily right there in your code, so you don't have to do things manually. And this is because we're tracing things like requests and the request lifecycle, right? Everything between the requests has come in, you've got your headers till we've sent the last byte, right? In order to track this across executions, and remember, Matteo, you're just talking about this, like servers can be handling many, many requests per second per interval, right? We are operating with a concurrency model here, not a parallelism model, but a concurrency model, meaning there's a lot of requests inflated at any given time. So we need a way of tracking them across an individual one. Again, this is where async local storage comes in handy.
And I mean, I love magic, but I also can sniff there is something wrong into all these goodies of, async context, async local storage. So I think I would love for you guys to share, first of all, which one are the trade-offs, because there's not such a thing as a free meal, and definitely this one is not a free meal. And then we can actually kind of like jump into a little bit the troubles that we can have in production, right? Because it's nice to see the trade-off, but also what are the variables that define the breaking point for all these goodies. So let's start with the trade-off. What are the trade-off of this super cool state? It's basically a state.
I think, Luca, it's better to start with what you can do with these kind of things and what are the problems we can debug, and then we can talk about the cost. Because talking about the cost of them before probably doesn't sound good, because those tools are great. Okay, so let's show how great they are, and then let's show how much costly they are. So you see,
a Ferrari is a beautiful car, but then you check the price tag and you realize you cannot buy it. So it's you do window shopping. So let's do some window shopping in technology. Let's brighten our eyes looking at something so shiny and cool, and then say probably it's too expensive.
Let me start for that. So so one of the things that you can easily fix, okay, or understand what the problems are with distributed tracing and these tools are essentially debugging very complex interactions. So let's say that you have another service that is randomly failing under certain condition that you don't know why, okay? You are issued some requests, but you're not getting any response, or you can, there is a lot of things that you cannot see sometimes. These tools allow you to get visibility of each individual step of that request or flow. And because it's of the auto-instrumentations that Bryan was talking about, you can essentially very quickly grasp that, you might have a problem with the DNS layer, for example. It's very easy because you have the information already in front of you. Okay,
this is not async context. This is Dapper, right?
It's based on Dapper. Okay, it's like you can't. The fundamental point is in order for Dapper and those tools to exist, okay, you need something like async context and auto instrumentation to exist at the same time, so that all the components have the tracing in place.
So just to rephrase the value, because I think, I think distributed tracing is clear, but it's not the async context. Is that in order for distributed tracing to store, like Bryan was saying, all the spans, you need to have a centralized place where to throw all this information, then recollect them or order them later on in time. Right?
Exactly.
Because
well, you need someplace other than the code that you're writing.
Yeah.
Right? Because The intent here is to make it so that you can write normal code, right? Normal handling of HTTP requests, normal whatever else you're doing, talking to databases, that sort of thing, without having to write extra code just to be able to get that visibility.
Yeah. Okay,
Right.
that makes sense.
So things like async context, async local storage, and the auto instrumentations that APM vendors do, these exist so that you can write normal code that doesn't have observability as the primary feature of it and still get that visibility, right? I was mentioning magic before. Yeah, sure. Sometimes magic is painful, but and we can talk about trade-offs in a second, like you were saying. But that is the benefit that we get out of this. This is the win. This is the value, right? It's that you can write normal code and get visibility out of it without having to keep track of things like context manually, right?
Cool.
Which, by the way, if you're writing performance sensitive components, it's something that you probably should be doing. Okay. If you're writing some piece of code that needs to be performant, you probably want to manage that. I have done it a few times, and it's actually fantastic. It costs nothing. Okay. It's absolutely has zero overhead on top. Okay. It's close to essentially an approximation of zero. So, however, it's work. Okay. You need to treat it like a massive additional feature or non-functional requirement that you're adding to your application, and it's work, as I said. But more importantly, it does not give you the same level of the complete level of visibility that you would get via an auto instrumentation solution, okay, which is the other side of the trade-off. So it's possible, but it comes with its own caveats. So this is pretty cool. So let's go a little bit deeper, Bryan, and then let's talk about the trade-offs, because it's also a trade-off, to be honest. So you're talking about magic, and let's try to see how the magic works, because it's no secret. You can find them on GitHub. It's all in the front of the eyes of everybody. But how does the magic work, and what does this magical component do? Let's unveil the trick.
Sure. So let's start with how things used to work, because that's fun. The way things used to work, we used to have a library, or basically a built-in feature of Node called async hooks. Async hooks gave us basically what we were getting out of the sort of implementation details of continuation local storage. In other words, we were getting sort of before and after every asynchronous operation, right? Using that, we could tie together async context sort of in an abstract sense, right? What it would actually do is say, okay, here is my current active storage, or an ID. That internally is talking about an ID, but on top of that, we would build a storage object, right? Which is then carried forward from the before and after. We use that ID as an index to tie the storages together. It might sound a little bit complicated, but the long story short is, if you think of everything being a map from IDs corresponding to your asynchronous context to a storage, that like the map's value is the storage. That's more or less what async local storage is, right? And so what that gives us is the ability to just have a separate space for variables, right? I said magic before. It's not really magic. It's just a map, right? It's fairly straightforward. The difference, though, is that it manages the lifetime of the map. So if a continuation is no longer valid, then you can no longer access the value in async local storage. That has garbage collection implications, which I imagine Matteo has some things to say about fairly soon. Especially if you're storing a bunch of spans in there, which like we do at Datadog, for example, right? So, or in OpenTelemetry or similar tools. So yeah, implementation details. It used to be async local storage. I was going to talk about promise hooks and such.
Okay, go for it. Go for it. Go for it. Yes, go for it.
Okay. So the issue with that is that with promises, that was a very expensive operation, because every time you call one of those async hooks, you're making a call into C++. Anybody who's done enough Node before knows that every time you go into C++, that you incur some performance overhead. And so on a promise, we're doing that something like twice, 3 times, 4 times. I forget the exact count, but enough times. 3 times, is that the last count?
That is an await. It's 3 times.
Oh, you're thinking await, right? Well, an await is 2 promises, right? So yeah.
And then plus the friendly additional tick, yeah.
Right. The friendly additional tick. Yeah.
It's 2, but it's 3. But okay.
Right. So the point that Matteo and I are getting at is that there are a lot of operations that would go into play whenever you do a promise-based asynchronous operation in Node when you had async hooks enabled. This could massively destroy performance. I've seen cases where people just put awaits and various other promise-based operations in their code. And we can talk about things like 10,000% overhead, okay? Because there are just so many more operations happening that probably don't need to happen. And I say probably don't need to happen because since then we've had a bunch of developments around this, particularly in promise hooks and other improvements, mostly put together by your colleague Stephen.
Your colleague before, so
right. While he was my colleague at Datadog, where we put a bunch of improvements that we're not making all of these calls into C++ all the time. There are features now built into V8 that basically reduce the impact of doing this, right? So the implementation of async local storage has been completely rewritten, and now it's a much less performance impactful operation. Right?
It's pretty cool. I did the first crank of it by dropping it from, I think, 25% overhead to I think 12% overhead, something like that.
Okay, when you say overhead, I have to ask overhead of what on what?
Yeah, exactly. You see, on my benchmark, it was I added there was a 25% drop in using it at that point in time. It was already reduced from 50 to 25 or something. Somebody else did that. Then I did the drop. I designed this thing. Execution async source that dropped it from 25 to 12-ish. Then the latest crank bring it down to 7, something like that. So I'm very very happy that all of this is a long story of optimizations. Okay, but there is a point here that we are missing. Okay, okay. So we know what we're storing data. Okay. However, we need to instrument every single operation that a node does, or your program does, or your library do. How does that happen?
Instrumentation is another fun. We could do a whole another episode of this on instrumentation, but just sort of high level. Instrumentation basically means we are shimming something, we are monkey patching something in a library, in Node core, wherever it happens to be, and then inserting whatever code is necessary to create the data for your APM tool, for OTel, for whatever else, right? And so monkey patching is the way we have traditionally done this. It was fairly straightforward in CommonJS because we could simply monkey patch require itself so that as soon as code is loaded, we have access to the entire objects that is your exports, and we can just change everything. A library called require in the middle sort of encapsulated all of this. Of course, it's called require in the middle because it's like doing a man in the middle attack, right?
Yeah.
So that library was great because it just encapsulated all of this. We didn't have to do much extra work. We could just say what library we want to instrument and then get access to it before it gets into your application code. Great. So this allows us to do our monkey patching in a nice sort of clean way that is, sorry to use the word again, but like magic to the user, right? Because it happens before their code has any access to it. So that's the beginning of the story. Things get weird when we talk about ESM. So ESM, for those listening, Matteo's making some pretty interesting reaction faces at this. ESM's great. People love ESM. It introduces a fun new syntax, import and export and all this, fun keywords and stuff. But it also does a completely different model for how code is loaded, right? It's not just a function that is called that we can just monkey patch and then we're good to go. And more than that, the things that are exported are externally immutable, meaning we can't just monkey patch whatever is exported. So
Maybe we can.
Well, maybe we can, right? But the spec doesn't allow it, right? So can we? Oh boy. So here we are. The ESM has been a fun problem for APM vendors and OTel pretty much since it's been included in Node. Sort of what's been kind of holding us back from having a probably a more complete solution to it is just the fact that most people tend not to deploy ESM. Okay, what does that mean? That means that most people will do some kind of transpiling step. They're doing TypeScript these days. I don't have like hard numbers on this, but like the tendency historically, at least going up till fairly recently, has been for folks to deploy what amounts to either common JS or bundled code, even if they're writing in something that looks like ESM to them.
Well, it's not ESM. It's folk ESM, as I call it.
Yeah, exactly. Faux ESM. So you know, it looks and smells. It's like duck type ESM or something.
Yeah.
But it's not, right? What they're actually deploying is either common JS or bundled code. Of course, bundled code is also difficult for instrumentation, because what do we have to interpose on? We don't have necessarily a require function that's obviously given to us. We end up having to write like bundler hooks and stuff in order to make that work. So in ESM, we have none of that, right? All we have is what the language provides us, which is immutable stuff. So what are we going to do? So thankfully, there's been a bunch of folks who have been basically tirelessly looking at what we can do in Node and working with V8 and so on. And now we have a feature in Node that's called, well, it's gone through several names. I'm just going to call it loader hooks because that's the way I think of it. Good enough. Please consult the Node documentation to see what it's called today. It's gone through several names. But basically what this gives us is a couple of lifecycle events for loading ESM code, right? The first one is resolve. So that tells us, you know, what is being resolved, like what is being imported, and like what's the URL or path or whatever, right? And then allows us to see what it will be resolved to, right? Is it an internal file? Is it a native built-in thing? What is it, right? And we can modify that if we want to. That hook allows us to modify that. So for example, you can redirect to a completely different file on the file system or elsewhere. And so that's the first hook. The second hook is load. And that basically gives you the source code. And the result of that operation is loaded exports effectively, right? So we cannot modify something that has already been loaded, right? We cannot modify exports. But what we can do is change the code, right? We can change the code, we can wrap it with something else and load something else. And those are the sort of techniques we have to think about here when we're talking about instrumentation for ESM, right? So our initial solution, and this was put together by Gus Kaplan, who was interviewing with us at Datadog at the time, was to basically create a wrapper module for every single ESM module, so that later on, if we wanted to modify it, we could modify it externally by relying on our ability to modify internally within the wrapper module. So we would change the exports of the wrapper module, but not of the original one. So we would do a misdirection in the resolve hook, and then we would change what we're loading in the load hook. I'm glossing over details. There used to be like 4 different hooks, and we'd have to deal with all of them. It was a total pain. Today there's just load and resolve. So yeah, that was important in the middle. We found a bunch of problems with this. And in fact, if you talk to other APM vendors, New Relic, Elastic, and so on, they will tell you the same. There are problems with this approach. We called this approach import in the middle, by the way, as a sort of homage to require in the middle. And now that's a Node.js project. We handed over maintainership to the Node project. But the problems were pretty huge. There are some rather popular libraries that I won't mention on this podcast that simply were incompatible for a bunch of interesting reasons. The biggest reason is because we were relying on interior mutability to mimic external mutability. Any module that relied on internal mutability would not work. So that was painful. Yeah. Yep. Again, for those listening, Matteo is doing quite the reaction now. Double face palm.
I know exactly the models you're talking about. So it's like
yeah. Oh, and I mean, also
pretty famous. They are pretty famous in the industry, in at least in our circles. But it's
yeah. Again,
they're
not
very popular though.
I will say this: the library where we first spotted this was using Open API to generate the APIs in question, and however way they had that configured was creating situations where it had to mutate the exports internally. So we started looking for other Open API modules, see if this was a trend. We didn't find it in any of the ones that we already instrument, so it's probably more widespread, or will become more widespread anyway. The fact of the matter is, people will want to modify their exports. That's just a thing, right? Perhaps after some initialization operation, who knows? Long story short, if code is possible, people will do it, right?
It's
so
too tempting not to do it.
Exactly. So we had to come up with another solution here. And the solution here ends up being we have to rewrite code, right? We basically have to rewrite code in place. We have to know what the code's going to look like. We can't try and mess around with exports and stuff because it's just too brittle. That wasn't the only problem. We could go into other problems, but that was probably the biggest problem, the fact that they were mutating themselves. So what can we do? Well, the right answer, or at least the closest thing to a right answer, because all of this is trade-offs all the way down, is we need to mutate code. So we already at Datadog had one of our products that's included in our library was already doing some source code transformation as part of one of our security products. So we sort of piggybacked onto that and started building a sort of code modification framework for JavaScript, basically, so that we can do very little more than insert instrumentations at appropriate points. So right now we have a framework where you can identify a function within code using a pretty straightforward query language, and then decide whether it's the parse will decide whether it's an async function or whatever, and then insert the appropriate tracing method around it. So we have that code. We named it after a similar product that we have for Go called Orchestrion. So now we have Orchestrion.js.
Pretty cool. I saw the demo of this in Paris, so it was your presentation was pretty good.
Coincidentally, at the Datadog office.
Coincidentally.
Yeah. Coincidentally.
So, but by the way, this approach right now is propriety of Datadog, but all the libraries are open source, if I understand correctly. So eventually, it might percolate down to OpenAPI and other vendors, I presume, because they are still using import in the middle more everybody else, right?
Right. So like OTel and other vendors are all generally using import in the middle today. That said, many of them, we can talk about names if we want, but like many of them are also paying close attention to Orchestrion.js, submitting PRs. While I'm on parental leave, there's a few of them kind of working on their own based on the Orchestrion.js code base to make the improvements that they want.
Pretty good.
I mean, yeah, it's great. This is a classic case of like open source and open source community stuff happening the way it should. Vendors, like competitors, collaborating instead of working against each other for basically core things.
That is a liability. Like that instrumentation piece is a liability. It's not value. Okay.
Right. It's a liability for an entire ecosystem of tools, right?
Exactly. Pretty much.
It's not just Datadog. It's not just New Relic.
If there is more than one, to do all these instrumentations, okay, it's a problem. Okay, it's a massive problem for everybody because it's a lot of work that is not fun to do, essentially. So.
But I think, Bryan, you just raised a very interesting point, right? That is aside of the async context and so on, is the fact that there are some core key components and features that are across vendors, across competition, that should be actually singly maintained with multiple stakeholders, right? The typical open source model. One starts, the other one contributes and improve over and over again. And I think this kind of model, we should promote it more and more and more for key components that are absolutely irrelevant for business advantage for many, many organizations. And also from a consumer standpoint, I mean, Matteo and I spoke a million of times about the Kafka situation. When you have multiple choices on what to use to connect to Kafka, which is completely redonkulous.
Or Redis, like there are
Yeah,
many such
already.
examples.
But then you have the vendors, right? The people that kind of like promote the use of this technology, that instead of contributing and creating something that can, everyone can improve upon, they create a new library. And then instead of actually reducing friction, they add even more friction and complexity into the user. So I think the point that you made is probably the best takeaway as some sort of like generic pattern coming from a vendor and say, it's useless that we compete on this functionality. Everyone uses, let's build it all together and move on and create better value for our customers. So that's probably something we should promote more.
Yeah, I mean, I like the way Matteo phrased it. Like, it's not a feature, it's not value, it's a liability, and it's a liability across everything. So everybody has to deal with it. Let's not waste our time, basically.
Correct.
So we talked about the benefit of it, the history of it, how it get through it. You can let me share a little bit. We talked about a little bit of war stories where this is useful. I think if you have never tried a distributed tracing or a tracing product for debugging some production issues, I think they looks like magic. As Bryan said, it provides infinite visibility on what is needed, and sometimes you can get you can get a lot, okay, and because you get
Infinite's a strong word, Matteo.
Yeah.
Okay. you get a lot of visibility on what is happening, and you can use that knowledge to make on an expert hands, let's put it this way, that knowledge would it's worth a lot, because you can now debug certain big problems that might affect a percentage of your users and know what's happening. Okay. Now it requires serious chop, but very often to know, like my main one of the things that I've seen in these patterns is companies and teams gathering all this data, putting out tracing dashboards and tracing all the products all together or something, and then you ask them, but what is your application doing? What problems do you have? They don't have an answer. Okay, and why you're spending all this money if you're not understanding what you're looking at? Okay, this is to be honest, my main concern. As in the past, I've done a lot of consulting on this, literally like being the one looking at Datadog most of the time, that's your problem. How do you know that's your problem? This is the typical question. Oh, because of all this bag of theory that I'm going to explain you, okay, and charge you. And then one single, it's the typical solution of, $1 for the hammer and $9,099 for the knowledge of where to hit the hammer, essentially, like one line fix type of thing, and massive value out of it. Anyway, I've done a lot of that in my previous life. So that is good, okay. But how much, if somebody, like, all of this magic does not come free, right? Does it have a cost in terms of how much I pay vendors, okay, and also how much is impacting my how much overhead is adding to my product, right? To how much more CPU and memory should I put on my servers?
Well, let's start with costs that you're paying to vendors. I don't really know the details of our pricing structure at Datadog, for example. I do know that that's out there. There are pricing models where, for example, you pay per seat, you pay per unit of data sent. That's an interesting one, right? For however many bytes you send, that kind of thing. That in most cases for across vendors, there is the ability to change how you are sampling, right? So how much data is actually being sent across to the back end to the services collecting your data. And so in cases like that, you can sort of tune it to whatever sort of suits your need to, find the correct trade-off for yourself when it comes to how much you're willing to pay in order to get how much visibility. So there's that to consider, and there's across vendors, as far as I know, the ability to change values like that. So that's so you can tune it for yourself, because this is definitely not a one size fits all thing. People have to pay for data egress and things like this, right? So it may not just be the vendor that you're working with that you have to pay, but also your cloud provider, right? Of course, it's at Datadog and most other vendors, we try to be in the clouds, inside the cloud service, close to where your app is deployed, so that you're not paying as much. But it's a very real concern for a lot of people. Okay, I don't want to talk too much about costs, because it's just not something that I'm most familiar with. If we want to talk about performance, oh boy, Matteo, you and I can talk about performance for days, right? So let's talk about performance.
Okay, so my take here, let me start with a provocative take, okay?
Okay.
Some years ago, not immediately, but some years ago, okay, one vendor, not Datadog, so I'm not naming them. You are here, so I can name you, but one other vendor, one other APM vendor, okay, was essentially it required 2x. So if I wanted to have tracing enabled with their system, I had to essentially allocate a full CPU and another gig of memory, essentially, just for their system, which was a Java app running to get near your Node app. And if you know, I don't know if you remember this, Bryan, but this existed at the time. Okay, they removed that. Okay, luckily. So that's not the case anymore, even for that vendor. But at the beginning, that vendor was doing that. Okay, essentially there was this npm module that downloaded the Java thingy. That was, wow, what is this thing going? Okay, imagine.
I mean, you and I have both seen weirder things than that. Like, that's not even that weird.
Yeah, no, exactly. You see, but the overhead was literally 100%. Okay, like it was literally, if your application needed 10 servers, now you needed 20. And probably because of the rules of distributed computing, probably 30 instead of 20. Okay, so I think the situation improved, right?
Yeah, I mean, like we alluded to earlier, there was a huge sort of CPU execution time performance hit of running something like AsyncLocalStorage. It's much less now with Node 24. So probably the biggest PSA for anyone who is running an APM tool, whether it's Datadog or OTel or a competitor or whatever, try Node 24 and see how it goes. That's probably the biggest thing I can say right now. So there's been a lot of performance improvement there. We talked about it earlier, a lot of the work that Steven has done and so on. But at the end of the day, your mileage may vary, right? Why MMV? Why? Because when it comes specifically to asynchronous context overhead, like the overhead of operating that whole system, it's extremely application dependent. You said 2x was the case for a particular vendor. Overhead is not something that is like static per library or tool that you add to your application. It's a function of that and the application itself. Pardon me. So when it comes to async context, async local storage, it's a function of literally every line of code can change what the overhead of that is. You can talk about situations where you have something that is imperceptible overhead. You can talk about situations where, like I said before, you see 10,000% overhead. So like, that's just the nature of what we're dealing with. Long story short here is everybody has to measure with their application and tune things accordingly. But We have done the work, across several companies at this point to improve the situation, particularly with async context overhead. It's not just async context overhead, though, right? You have other things going on in the process in order to enable APM vendors and similar tools, other observability tools, right? So, for example, we have to store the span data structure, right? This is actually like part of OTel is that the span data structure is available also to the programmers. So it basically has to be there in process in one way or another. That's true for OTel. That's true for Datadog. I'm sure it's true across vendors as well. So by having that data structure in there, problems that involve, for example, requests that don't end when they should, things like that will be exacerbated, right? Because now you're talking about things that are holding on to. I mean, well, you've talked about this. I've talked about this before. It may look like a memory leak, but it's really just consuming tons more memory than it should.
Yes, I am very familiar with the problem, especially for fetch. This is look how we should do an episode on fetch at some point. This is a fun one. Okay.
No,
if you want to do another
examples.
If we do 3 nerdy episodes, people are gonna fall asleep and we lose 50%.
Nerdy episodes, man. This is the Node banter. There are going to be some nerdy episodes.
Yeah, but they like everything. You cannot eat pizza every day, even if it's good. Even if you go to Italy, Brian, you cannot eat pizza every day. You need to take a break. You need to eat a salad sometimes. You need to relax. You need to enjoy. So we're gonna do this kind of like wavy thing, but we're gonna
I'll take a break from pizza and have my porchetta. Yeah, for sure.
Exactly. It has to go light. But guys, I'm checking the time because we have I'm also Swiss, so it's all about time. And I would love actually to close up the last few minutes with some sort of like pill that the people listening can kind of like take and think about. So maybe if you want to share, Bryan, a suggestion, a recommendation, something to watch out, something that you think is a great takeaway for the people that they were, following the conversation. And definitely, you said it, we should have another episode. So you just self-invited yourself for our next episode, Bryan. So
I'll be
check your email for the next invite. But what would be actually this takeaway, this thing that you say, hey guys, in this context, this is something that you should kind of like keep in mind or use or whatsoever. You are free to give the pill to people.
Okay, a number of things. One, use Node 24. Like, stop messing around. Use Node 24. The main thing is if you're using anything that depends on AsyncLocalStorage, Node 24 just simply will be better. That's it. The other thing here, if somebody says the overhead is X, they're probably misleading you either intentionally or unintentionally. Measure for yourself. That is the only real true answer you're ever going to get. You have to measure for yourself with your own application because, again, all of these things are a function of the application. Those are the two biggest things. I guess another thing is if you are a library author and you're doing something that breaks asynchronous context, we haven't really talked about that much, but please don't. Please don't break asynchronous context. It destroys async local storage for folks, not just for SAPM vendors, but for anyone using them or using the tools directly. So if you want to learn how to not break asynchronous context, if you're doing something that does today, just look at the Node docs for async resource. It's designed to allow you to not break asynchronous context. Yeah, I think those are probably the most important messages.
Cool. And Theo, do you have any other pill that you want to add?
I echo Bryan in measure for yourself. Okay, you have to measure this with an empty load. Okay, we'll give you certain results. Okay, and we'll show you a significant level of overhead. But most applications have significant overhead themselves. Okay, and unless you are essentially serving data from a memory cache, you probably are doing some heavy CPU process, some relatively heavy CPU process, like a 1 millisecond CPU processing. It's heavy for me, but probably not for you or for most people. Okay. Or you're doing a lot of database interactions that will, slow things down anyway for that purpose. So this is the TLDR. When you put those things in place, you might not even notice any overhead from using those solutions, because simply put, they're not your bottleneck. So if they are not your bottleneck, you can just enjoy the benefits without having any overhead on your app. Okay. If they become your bottleneck, well, then you probably need to start treating observability as a main core feature of your app, because otherwise you are in trouble anyway. Okay, you are on a very narrow niche at that point. Okay, so I think I summarized it. My thinking here. There is a lot on this topic. Okay. There's a lot on the history of this topic. Bryan gave you a very nice overview. And I have a lot of stories, a lot of friends met along the way, a lot of friends that are not doing Node work anymore, and some friends that still are.
Good for them. Good for them.
Good for them. Okay, I'm very happy to still be doing Node work. So I think that would be cool.
Super, guys. And after proving once again that Einstein was right about the measurement and the observer, I think we want to thank you, Bryan, for this beautiful chat. Have been extremely insightful, especially for me, to also walk through the history and the thought process went behind certain decisions and certain technologies. And so we cannot wait to have you again, Bryan, in another chat, another nerdy chat. And Theo, you and I are going to meet again next week, same time. And
same time, same place. Bye, folks. Bye,
ciao, everyone. Ciao, Bryan.
Ciao. See you later. Thanks for having me.